So today we are looking at problem number 322, coin change from LeetCode. What this problem states, you are given an integer array coins representing coins of different denominations and an integer amount representing a total amount of money, and what we want to return the fewest number of coins that you need to make up that amount. If that amount of money cannot be made by any combination of coins, then return -1. And they have also given that you may assume you have an infinite number of each kind of coin. So basically we need to find out or try out all the combinations of coin. We need to find out minimum number of coins that makes this amount. So when we say try out all the possible combinations, then we can think about the recursion. So let me write down. Try out all the possible combinations. Find the combination that has minimum number of coins. This gives intuition of solving problem with recursion. What are the general steps we have to follow in this case? First step will be express the given problem in terms of index and the target. Second, express all the possibilities like tech, not tech. Third will be find the minimum of possibilities, that is minimum of tech comma not tech. And fourth is find the best condition to terminate the recursion. So if we follow these steps, we will be able to find the combination that has the minimum number of the coins to give that particular amount. So if we think about the example given here, first example, which has the input coins array as 1, 2, 5 and amount is 11 and output is given as 3. So with minimum 3 number of coins, we can make the amount as 11, which is nothing but we are taking 2 denomination of 5, 1 denomination of 1. So there could have been another example with 5 denomination of 2 and 1 denomination of 1. Then 5 plus 1, 6 number of coins with 2 and 1. Or take 11 denomination of 1 and make amount as 11. So out of all the possible denominations, 5 plus 1 is one combination which has a minimum number of coins. So to see all the possible combinations, we can try to find out how the recursive tree will look like. So let's see the recursive tree with the example of array. Suppose 1, 2, 3. So at 0th index, 1 coin is there with 1 denomination. At first index 2 and second index 3. And our amount is suppose equal to 8. So if we express this particular problem in terms of index, then we are starting with index n minus 1 and our target amount is 8. So there could be two possibilities. One is pick, another is not pick. So if I consider not pick, then we will be just going to the previous index, suppose 0, first, second. So if I just consider this with respect to the position, if I do not pick this, then I will go to next index, that is first, and I will keep the target amount as it is because I did not pick it. And if I pick it, then in that case, as there are infinite number of denominations for the same coin, then what I can do, I can stay at the same index, but my target amount will reduce by 2, so my target amount will be 6. So in this case also, no, but here, sorry. Yeah, in this case, if we see at second index, what denomination we are having? 3 rupee. So 8 minus 3 will be 5. So basically 5 will be my remaining amount. But in this case, if I go here, again, my recursive tree will move like pick and not pick. So here, if I am not picking, then again, I will go to 0th index. From here, I did not pick 1. So I went at the 0th index. So target amount will be same as 8. And in this case, if I pick this, so what will be the target amount? Here, I can stay at the same index because I can take infinite amount of coins. So just my target has been reduced with the 2 because at first index 2 denomination is there. And if I go further, for this also there will be two possibilities. One is not pick. If I am not picking it, then 0th index and my target amount stays as 6. And if I am picking it, then it will reduce by again 2 rupees and my target amount will be 4. And again for here, so here I've reached up to the 0th index, so I will return 6 denominations. Here I am returning 2. Again there are two possibilities, either I am not picking or picking. So if I am not picking the coin, then it will go at the 0th index, but the same amount it will carry as we are not picking it. And if we pick, then it will be, we are staying at the same index, but amount will reduce by the same 2. And once we come at, so it reached at the 0th index, then we are returning the 4 denominations. But in case of 1 comma 2, again if we try, there are two possibilities. One is not pick, another is pick. So it will be just reducing the index but not picking, then the amount will stay as it is. But here in this case, if I am picking, amount will reduce to 0. So from here, I'll be returning 2. And here also, now my target amount has reduced to 0, so I don't have to further calculate. So I will be returning. So total number of denominations means like 2, 2, 2, but plus 1, plus 1, plus 1, and plus 1. So if we consider all these possibilities, then 1 plus 1 2 plus 1 3 plus 1 4. So 4 coins of 2 can make amount 8. So like this we can try out for the right branch with 2 and 5. So this is how the recursive tree will look like. So now let's go to the solution as we mentioned in the starting. So we'll just write the code now. Int n is equal to what is the coins length, and our final answer is nothing but the number of minimum number of the possible coins with which we can make this amount. So for that we are writing the utility function in which we are passing our index. We are expressing the given problem in the terms of index, then target amount. Target amount is here we are just passing amount, and we can write further how our definition of that particular function. So private, it is returning int, then the function we have passed index, and then int array coins comma int target amount. So here we will have two possibilities. First possibility, if I consider with respect to not taken, then what it could be, we are not picking the coin at that position, then we will just move to previous index as we are moving from the n-1 to 0. So it will be index -1, and we are passing the coins array, and amount will stay as it is. And in case in taken in take, so as we want to calculate the minimum number of coins, so we will consider as like with respect to int of 1 e9 we can consider, or integer dot max value. So just take example now, like if we write tech, so how tech will look like, tech equal to, we have taken that particular denomination at that particular index, so one count for that, and then we are moving further, but again taking the same index, so we will not reduce it by 1 because infinite number of coins for each denomination, but the amount will reduce by the coin which we took at that particular position. So we are just reducing target amount. And can we take always, or there will be one condition which is like coins at that particular index is less than equal to the amount, then only we can take, otherwise we cannot take it, right? So if I just format this code again, okay, and at the end what we want to do, return the minimum of take and not take, right? So mat dot minimum not taken comma taken. So this will be our recursive solution. Now what is missing here? Base condition. So what will be the base condition in this case? As we are traversing from n-1 to 0, so as index is become equal to 0 and coins at the 0th position is equal to, then we can return what is the denomination at that position, else we will return too much big amount. So this is our base condition. We'll check here, means it greater than the largest number, else we can return answer. Yeah, so this is how we have written the recursion function, and further we can optimize it by using memorization. We'll see it in another video. Let's code together, let's grow together. Thank you.